recording something and all and. Welcome students. Welcome to St. Joseph's open web-based learning platform. So we learn for a soulful and enriching e-learning experience. Welcome to Department of Mathematics. Our topic name is Differential Equations. Instructor for this chapter B. Bharati, MSc, Mathematics, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Autonomous, Vishakhapatnam. Learning outcomes. Students learn to identify homogeneous differential equations and understand the concept. Second point, students learn systematic techniques to solve homogeneous differential equations. Third point, they develop skills to verify whether a given differential equation is homogeneous and understand the implications of homogeneity on the behavior and form of solutions. Fourth point, student will have a working knowledge of basic application problems. Let us see the content of this topic. Introduction to homogeneous differential equation. Second one, definition of homogeneous differential equation. Third point, working rule to solve homogeneous differential equation. And fourth one, related examples. Introduction to homogeneous differential equation. A homogeneous differential equation is an equation containing a differentiation and a function with a set of variables. Definition of homogeneous differential equation. A first order differential equation m of x comma y into dx plus n of x comma y into dy is equals to 0, where m and n, these two are continuous functions of x and y respectively, is called homogeneous if m of x comma y and n of x comma y are homogeneous functions of x and y of the same degree. This differential equation can be written in the form dy by dx is equals to f of x comma y. Here f is a continuous function. A function f of x comma y is said to be homogeneous function of if f of lambda x comma lambda y is equals to lambda power n f of x comma y, where lambda is a constant, and make sure that lambda must be non-zero value. Let's see the example. F of x comma y is equals to y square plus 2xy. Here our function is y square plus 2xy. Let's calculate f of lambda x comma lambda y in order to find the degree of the homogeneous function. So wherever we have value x, wherever we have variable x and y, just replace with lambda x and lambda y. So here our function is y square plus 2xy, no? Instead of y, replace with lambda y whole square plus 2 into x means lambda x into lambda y. Move on to the next line. Lambda square into y square plus lambda into lambda square into 2xy. Next line. Take lambda square as a common. Y square plus 2xy. Therefore, we got f of lambda x comma lambda y is equals to lambda square into f of x comma y. Power of lambda indicates the degree of the given homogeneous function. Let us see working rule to solve homogeneous differential equation. First, put the given equation in the form m into m of x comma y into dx plus n of x comma y into dy is equals to 0, and let it be equation 1. Second point, we have to check m and n are homogeneous functions of the same degree or not. Third point, we are choosing y is equals to vx And fourth point, we are going to do derivative on both the sides with respect to x. Differentiate y is equals to vx to get dy by dx is equals to, applying uv derivative for the right side part, uv derivative formula is u into v dash plus v into u dash. Using that formula, we got v plus x into dv by dx. Fifth point, put this value of dy by dx into equation 1 and solve the equation for v by separating the variables. Sixth point is replace v by y by x and then simplify. Let us see example 1. Solve the given differential equation is xy into dy is equals to x square plus y square whole into dx. Solution, given that xy dy is equals to x square plus y square whole into dx. Move on to the next line. What we did here means send xy terms to the right side part and bring dx to the left side part. Then it becomes dy by dx is equals to x square plus y square by xy. Next line, according to the working rule, take y value is equals to vx. So put y is equals to vx. Move on to the next line. We are going to take derivative with respect to x on both the sides. So dy by dx is equals to, applying uv derivative for the right side part, that is u into v dash plus v into u dash. So we got v plus x into dv by dx. First write down right side part first. v plus x into dv by dx is equals to dy by dx. We already have a value. Just replace with that value, x square plus y square by xy. Move on to the next slide. Next line, v plus x into dv by dx is equals to x square plus, in place of y we have a value that is vx, replace with that vx whole square by x, as it is in place of y, replace with vx. After simplifying the previous line, we got v plus x into dv by dx is equals to x square plus v square x square by vx v into x square. Move on to the next line. Write down left side part as it is, that is v plus x into dv by dx is equals to, take x square as common from the numerator. So x square into 1 plus v square by v into x square. Here x square cancel. Move on to the next line. Send plus v to the right side. Then we got x into dv by dx is equals to 1 plus v square by v minus v by 1. Next line, x into dv by dx is equals to, if you take LCM, we got 1 plus v square minus v square by v. Again write down left side as it is, x into dv by dx is equals to, if you look into the right side part, plus v square minus v square cancel, leftover part is 1 by v. X into dv by dx is equals to 1 by v. Next line, we are going to separate v variables as one side and x variables as another side. And after that, we are taking integral on both the sides. So directly here we written integral v into dv is equals to integral 1 by x into dx. As we all know, the formula for integral v and integral 1 by x is, integral v formula is v square by 2 is equals to, integral 1 by x formula is log x plus c. Move on to the next line. Resubstituting v is equals to y by x into the above equation. V square by 2, no? Write down 1 by 2 in place of v, replace with y by x whole square. That means we got y square by 2 into x square, which is equals to log x plus c. This is the required solution for the given differential equation. Let us see example 2. Solve the given differential equation is x cube plus y cube whole into dy by dx is equals to x square into y. Given boundary conditions are y is equals to 1 when x is equals to 0. Solution. Given that, write down the given solution here. X cube plus y cube whole into dy by dx is equals to x square into y. Next line, what we did here means throughout inequality we are going to divide it by x cube plus y cube. Then the left side part x cube plus y cube by x cube plus y cube get cancelled. Leftover thing is dy by dx, which is equals to right side part becomes x square into y by x cube plus y cube. According to the working rule of differential equation, homogeneous differential equation, we are choosing y is equals to b into x. Move on to the next line. We are going to take derivative on both the sides with respect to x. So left side part becomes dy by dx is equals to, if you apply ub derivative here, u into v dash plus v into u dash, using that formula this can be written as v plus x into dv by dx. Move on to the next line. First write down right side part here, that is v plus x into dv by dx, which is equals to x square into vx by x cube plus vx whole cube. How did we write this line directly means, first of all we should replace the value of dv by dx, then after substitute y value, in y value is vx. Then we directly written x square into, in place of y, vx divided by x cube plus y cube means vx whole cube. Move on to the next line. Write down the left side part again as it is. V plus x into dv by dx is equals to x square into vx becomes x cube into v by, if you take x cube as common from the denominator, it becomes x cube into 1 plus v square. Here x cube get cancelled. After cancellation in the previous line, we are left over with v plus x into dv by dx is equals to v by 1 plus v cube. Move on to the next line. What we did here means send plus v to the right hand side. Then it becomes x into dv by dx is equals to v by 1 plus v cube minus v. Minus v can also be written as minus v by 1. Move on to the next line. X into dv by dx is equals to, what we did here means taking LCM on both this, taking LCM or cross multiplication. Then it becomes v minus v power 4 by 1 plus v cube. Here plus v and minus v get cancelled. Move on to the next line. Left side part again as it is, x into dv by dx is equals to, after plus v and minus v get cancelled, left over part is minus v power 4 by 1 plus v cube. And in the next line, we are going to separate v variables as one side and x variables as another side. And after applying integral on both the sides. So it becomes integral 1 plus v cube by v power 4 into dv is equals to integral minus 1 by x into dx. Move on to the next line. Apply integrals separately, or for each and every term we are going to apply this integral. So integral 1 by v power 4 plus integral v cube by v power 4 into dv is equals to minus integral 1 by x into dx. Continuation part of the previous slide. Integral v to the power of minus 4 into dv plus integral 1 by v into dv is equals to minus log x plus c. Move on to the next line. Integral v to the power of minus 4 formula is v to the power of minus 4 plus 1 by minus 4 plus 1. It becomes v to the power of minus 3 by minus 3. So that is how we got v to the power of minus 3 by minus 3 plus integral 1 by v into dy formula is log v is equals to, write down right side part as it is, that is minus log x plus c. Again from the working rule we are going to put v is equals to y by x, or we can write y is equals to vx. Move on to the next line. V power minus 3 can be written as 1 by v cube, no. So minus 1 by 3 into v cube plus log v is equals to minus log x plus c. Move on to the next line. Minus 1 by 3 into, wherever we have v, just replace with y by x everywhere. So minus 1 by 3 into y by x whole cube plus log of y by x is equals to minus log x plus c. Move on to the next line. Reciprocal of the denominator part is minus x cube by 3 into y cube plus, as we all know the formula of log of a by b, that is log a minus log b. Using that formula, it can be written as log by minus log x is equals to minus log x plus c. Write down the same step which is there in the previous slide, that is minus x cube by 3y cube plus log y minus log x is equals to minus log x plus c. Move on to the next line. Minus x cube by 3y cube plus log y minus log x. Bring minus log x to the left side part, then it becomes plus log x is equals to c. Move on to the next line. Minus x cube by 3y cube plus log y. Here plus log x and minus log x get cancelled, which is equals to c. Coming to the next line, put y is equals to 1 and x is equals to 0. Question itself the given boundary conditions for the given differential equation. So now we are going to substitute these two conditions on the above step. So minus x cube means 0 cube by 3 into y cube means 1 cube plus log y. Y is nothing but 1, no? So log 1 is equals to 0. Anyhow log 1 value is 0. 0 by anything is 0. Finally we conclude c value is equals to 0. Just substitute c value in the above line. Then we conclude minus x cube by 3y cube plus log y is equals to 0. Instead of c we got the value 0, no, just substitute. Minus x cube by 3y cube plus log y is equals to 0. That is how we got required solution for the given differential equation. Thank you everyone for sparing your valuable time.